Hello students, how are you? Today we will talk about the representing of organic molecule. We know that there are millions of organic compounds existing now a time, and there are only three ways or three formulas through which or by implementing we can represent an organic molecule, such as molecular formula, which shows the actual number of atoms present in a molecule present in an organic compound. And the second one, if we talk about empirical formula, which shows the simplest whole number ratio of an atom of element in a molecule. Likewise, structural formula, which shows that how atoms are joined together and what are the sequence of atoms between them. Means every system, every formula, or every type gives the different information of representing a organic compound or a organic molecule. So let's discuss about the first one, that is molecular formula. Molecular formula basically shows the actual number of atoms present in a molecule. It does not give the information about the nature of functional group and the nature of bonding. Either there are single bond, multiple bonds, either the functional group is alcoholic, carboxylic. It does not give the information about the functional group or multiple bonds or the nature of bonding. It just shows, or it just gives the information that how many atoms are present in an element of a molecule. Such as, let's take an example of butane. We know that the structural formula of butane is this one, CH2 CH3, but this is not the molecular formula. Molecular formula just shows the actual number. Say for example, if we want to write the molecular formula of butane, we first of all we should count the number of carbon atom. How many carbon are present? Carbon 1, 2, 3, 4. Then we will write here there are 4 carbon. Now there are how many hydrogen atoms? Then we will count 3, 2, 5 plus 2, 7, 7 plus 3, 10. And there are 10 hydrogen atoms. So this is the molecular formula of butane. It means molecular formula does not concern about the nature of bonding, that how many bonds are present between the molecules and what type of bond, either single bond, double bond, or triple bond. It does not give the information about. Or the second is, it does not shows how many atoms are linked and how the nature of functional group. It does not about gives the information of functional group. Say for example, if we talk about the second example, that is ethanol, CH3 CH2 OH. We know that according to the structural formula, this is the functional group and this is a single bond between the carbon atoms. But molecular formula just concerned with the counting of atoms in a molecule. Say for example, how many carbons are present in there? Carbon 1 and 2. So we will write C2, and keep it in your mind, we will write the number in the. If we count carbon atoms, there are 2 carbon, 1 and 2. But if we count hydrogen atom, there are 3 plus 2, 5, 5 plus 1, 6. Then we will write here H6. And how many oxygen? There are only 1 oxygen. So the molecular formula of ethanol is C2H6O, in which we cannot observe, that we cannot decide, or we cannot conclude it that which type of functional group is present in ethanol. But if we talk about its structural formula, then we can conclude, and we can finally decide that OH is present as an alcoholic group in the alkyl alcohol, in the alkyl. So it will be ethyl alcohol or ethanol. But according to the molecular formula, we can't even recognize the compound, recognize the functional group. So this is all about molecular formula. The second one is empirical formula. Empirical formula basically shows the simplest whole number ratio of the atoms of element in a molecule or compound. What does it mean? Now let's understand the meaning of simplest whole number ratio. Say for example, if a math problem, say for example, a problem is 2 by 4, and the question is write the simplest whole number ratio of 2 by 4. Then you will write the multiple of 2 is 2 and 4 is 2. 2 ones are 2 and 2 twos are 4. The answer is 1 by 2. And we can say that 1 by 2 is the simplest whole number ratio of 2 by 4. Empirical formula work on this principle, on this rule. Now let's take a particular example, such as benzene. We know that the molecular formula of benzene is C6H6. And if we talk about the structural formula of benzene, we know that it is a 6-corner compound having alternate triple bond. This one. This is basically the molecular formula. If we talk about the empirical formula, then we will write 6 ratio 6. This 6 is for carbon and this 6 is for hydrogen. And the simplest whole number ratio of 6 ratio 6 is 1 ratio 1. So this one represent the carbon and this one represent the hydrogen. So empirical formula of benzene is CH instead of C6H6. C6H6 is basically the molecular formula, in which there are actual number of atoms present in a molecule. But empirical formula shows the simplest whole number ratio of the atom of molecule. So the benzene have CH as an empirical formula. Hope you will understand. If you have any question or query, do comments. Now let's talk about structural formula. Structural formula basically describes the sequence of atom and how atoms are joined together. Means the we can say the nature of bonding, the nature of functional group. Each and everything is represented in the structural formula, and there are further three types of structural formula. The first one is displayed formula, which we can also say a graphical formula. Second is condensed formula, also known as linear formula. And the third one is skeletal formula, which is also known as bond line formula. First, we'll discuss about the displayed formula. Displayed formula is the first type of structural formula which shows all the bond between the atoms, including lone pair and functional group. What does it mean? Let's take an example. If we talk about ethanol, this is the molecular formula of ethanol. Now, we conclude or we write the structure formula of ethanol here. As I discussed, shows all the bond between the atom. It means first carbon, second carbon, and having three hydrogen atoms. And structure formula shows all the bonds. In molecular formula, usually mostly bonds are omitted, but in structure formula, all the bonds will be shown. And here is OH as a functional group, and here will be H2, first hydrogen and second hydrogen. According to the structure formula, the displayed or graphical formula of ethanol is this one, in which carbon to carbon and carbon to hydrogen and carbon to function group, each and every bond, either they are multiple, either they are single, either the nature of functional group, either the nature of bonding, each and everything is described by the displayed formula. Displayed formula is the, we can say, a space consuming formula in which every ingredient we can show. So this is all about displayed formula. If we talk about another example, such as butane, we know the molecular formula of butane is this one, and structure formula is one. But if write the displayed formula of butane, we will write first carbon, second, third, and fourth. And we know that the valency of carbon atom is 4. So we will assume, or we will write hydrogen for every spare bond of carbon. So this is all about the displayed formula. The second formula is condensed formula, or also known as linear formula. Its specification is that use less space, single bond usually omitted, and branches, functional groups, multiple bonds, and separating methylenes are shown in brackets. What does it mean? It means that the same type of methyl group, same type of side chain, or same type of same type of groups will be condensed in such a way the number of molecules, the number of branches will be written in the subscript. Say, for example, if we talk about butane, butane have two CH2 groups in between CH3, just like that, CH3, CH2, CH2, and CH3. So the same groups will be condensed. So this is that's why this is called condensed formula, because the same groups will be condensed in the formula, and it is a less space consuming formula. And this is the example of butane. This is all about condensed formula. If you have any question, please do comments. Last one is skeletal formula, which is also called bond line formula. It tells basically a simplified form of displayed formula. Carbon and hydrogen symbols are omitted, like line shows bond between the carbon atoms. Each corner or end represent carbon atom. Enough carbon hydrogen bond assumed to complete 4 bonds. What does it mean? Let's take an example, then you will understand better. First, I write simplified form of displayed formula, and displayed formula is this one. If we talk about butane, this is the structural formula of butane. Now, I mentioned the characteristics that every corner or every end, means this corner, this end, and this end will be assumed as carbon atom, and the symbol of carbon and hydrogen are omitted, means we cannot write the symbol of carbon and hydrogen. Instead of, we assume each end and each corner of carbon atom, means every corner represent a carbon atom. And we will assume, we will assume the hydrogen atom for the spare bond of carbon. Say, for example, this carbon atom and this carbon atom having one bond, so this carbon have further 3 bonds spare. So we will assume the spare bond will be bonded with the hydrogen atom, but we cannot write it in the skeletal formula. So this is the structure of butane. Enough carbon hydrogen bond assumed to complete 4 bonds, means there are how many there are the spare bonds of carbon atom. We will assume there that there would be hydrogen atom. This is the example of butane. If we talk about ethanol, uh, ethanol basically consists of 2 carbon, means 1 carbon and second carbon, but the third carbon contains OH group. Better keep it in your mind that functional group will be shown or multiple bonds will be shown. I have multiple bonds and functional groups are shown. What does it mean? Because ethanol contains a functional or alcoholic group, it will be shown. Its symbol will be represented. But the carbon and hydrogen will never be represented in the skeletal formula. Let's take another example. If we talk about butane, instead of butane, then we will write a double bond. Say, for example, we assume there is double bond. Carbon number 1, carbon number 2, and 3. Carbon number 1, carbon number 2, and here is double bond. So this is the formula of not butane. This will be the formula of butene. And double bond will be shown according to the skeletal formula. Hope you all will understand. Now summarize the whole topic. Molecular formula talk about the actual number of atom, where empirical formula shows the simplest ratio of the atom of molecule. Structural formula shows how atoms are joined together and how atoms are connected, and the atoms are connected in three ways. First, in displayed formula, in which all the bonds will be shown of an organic compound. Second is condensed formula, in which the same groups present between the compound will be written in a bracket and the number of groups will be written in the subscript like that. And last is skeletal formula in which the carbon and hydrogen atoms, the symbol of carbon and hydrogen atom will be omitted, but the functional group and multiple bonds will be shown like that. And the corner and endpoints will be considered as carbon atom, and the carbon and the rest of the carbon atom, sorry, rest of the bonds of carbon will be assumed that there should be hydrogen atom. There will be hydrogen atom. Hope you all will understand.